In this lesson, you're going to learn equations, inequalities, and graphs. Several types of equations that we have normally solved, including quadratic equations as well as absolute value equations. So we're going to pay attention to absolute value equations in this particular chapter. You can solve an absolute equation using algebraic method, which is you're going to break it into two cases. Then you're going to solve the overlap regions, and you're going to conclude and present the final answers. You can also solve it using graphical method. We're going to focus on the algebraic methods first. For example, when you have 2x minus 4 equals to 6, this is an absolute function. You can see the modulus sign being placed. So you're going to assume positive 2x minus 4 equals to 6 as well as negative bracket 2x minus 4 equals to 6. Because what modulus does is it gets rid of the effect of plus or minus. So even if it's a minus, you only see the value sign of it, right side of it. So we're going to break it into these two cases. 2x minus 4 equals to 6, 2x equals to 5, 2x equals to 10, x equals to 5. 2x plus 4 equals to 6, 2x equals to 2, x equals to 1. So that's how we got these two solutions. Similarly, in the next example that you can see at the bottom, if you would like to solve 3x plus 1 equals to 2x minus 5, again, you're going to break it into 3x plus 1 equals to 2x minus 5, as well as negative 3x plus 1 equals to 2x minus 5. So then you will solve them algebraically. So x equals to negative 6, negative 3x minus 2x equals to negative 5 plus 1. And in this case, you're going to get negative 5x equals to negative 4, x equals to 4 over 5. So these are the two x values for each of the case. Then you will be able to conclude the answers. So for these practices, we are going to do the same thing. For the next questions, this is a quadratic equations. So we also learned in the previous chapters that you can use the quadratic formula to solve it. A is 2, B is 3, C is negative 5. So you will get negative 3 plus 7 over 4 or negative 3 minus 7 over 4. X equals to 1. X equals to negative 11 over 4. So these are the two answers. When it comes to inequality, the approach is going to be similar. However, we have to be careful for quadratic. When it comes to the number line, it will follow plus minus plus. For cubic, on the other hand, it will follow minus plus minus plus. And for absolute functions, if we would like to solve absolute functions in the context of inequality, this is how it can be done. First of all, you will try to simplify it. So you get x minus 1 bigger than 2. Then you're going to break it into two cases. Remember, you have positive x minus 1 bigger than 2 as well as negative x minus 1 bigger than 2. Then you're just going to solve it as how you would normally solve it. So x bigger than 3, x smaller than 1. That's the reason why these are the answers. For cubic equation, similar approach would be taken. 3x squared minus 4x minus 5 smaller than 0. First of all, we will need to find the roots. In this case, the roots are not going to be integers, so you can make use of calculator to also find the roots. The roots turn out to be 2.12 as well as negative 0.79. So again, negative 0.79 is the smaller value, is on the left. 2.12 is the bigger value, is on the right. Plus, minus, plus. Smaller or equal sign was observed, so we choose the region in between. Therefore, x has to be in between 2.12 as well as negative 0.79 for this to be satisfied. These are the practices you can practice. Solutions are as the follow. Break into two cases. So, bigger than 4, smaller than 0. In this case, because it only has one repeated values, so we are going to talk about just for it to be bigger than that. Sometimes you will face into a situation where you will see quadratic equation in disguise, which means you have to make an additional substitutions. And in this particular case, for example, we're going to let y equals x squared to simplify it. This is a x to the power of 4, a quadratic equation, so it is almost not possible for us to solve it. So we are going to let y equals to x to the power of 2. So you will have y squared plus y minus 12 equals to 0. From this step onwards, everything is very similar to what we have been doing. So you can use the method, the factorization method for an example. So this is positive, negative, y plus 4 equals to 0, y minus 3 equals to 0. Something tricky also should be aware of. In this case, your goal is to solve x, not y. So you have to satisfy it for x. For example, x squared equals to negative 4 is impossible to continue. So this has to be rejected. And x squared equals to 3 is the only possible way to move forward. So x equals to square root of 3, x equals to negative square root of 3. And that will be the answer. Now, even though we are not learning, we have not yet learned exponential equations, logarithmic equations, but it is good to notice that similar types of method substitutions, for an example, are going to also be used for a complicated, seemingly complicated question that looks like this. This is almost impossible for us to process. However, if you let y equals to ln x, you can rewrite this as 2y squared minus 3y plus 1 equals to 0. And here's the key points. The key points over here is we once use substitutions, we can then make something possible. We're not going to solve the remaining because that involves further knowledge, such as solving exponential, solving logarithmic. So we will stop here. Similarly, all these practices are only wanting you to practice the substitutions. So you're going to let y equals to e to the power of x. So you can rewrite this as y squared minus 5y plus 6. Likewise, y equals to ln x. You can rewrite the second questions into 4y squared minus 4y minus 8 equals to 0. Then you will be able to solve this quadratic equation in no time. At the end of the day, you will then transform this quadratic equation y value back in the form of the x value, so you can get the final solutions. You will learn also how to kind of sketch the graph of cubic equation. Now, of course, you have to first determine its solutions on the x-axis, because then it is important for us to know how and when it will cross it. For example, when x equals to 1, -2, and 3, this is how it looks like. Cubic equation is similar to linear equation. It will grow from the bottom left to the top right. Okay, so if the highest power remains to be positive, if the highest power is a negative, then of course it will grow from the other way around. So in this case, the highest power is a positive, so we know it will grow like that. Since it has 3 x-intercepts, so it means it will surely pass through all these 3 points at least once. So this is the only possible way to draw cubic equations of this page. Now, similarly, again, we realize that x to the power of 3 is positive. X to the power of 3 is positive. We can determine the x-intercepts. So in this case, it's -3, -1, and 2 for the first question. For the second question, it's going to be -3, 2, and +4. Again, it will start from the bottom left, pass through all these x-intercepts, and these are how the shape of these cubic equations are going to be like. When it comes to solving cubic inequalities, remember what we mentioned earlier. The only difference is it follows a different set of number lines rule. The number lines rules for cubic equation is going to be negative, positive, negative, positive. Right? It doesn't start with positive, rather it starts with a negative. So if you have this as the root already, so for an example, -2, 1, and 3 are the root. Again, negative, positive, negative, positive. So you see bigger means you choose the positive region. So the solutions for the first questions is going to be x in between -2 and 1, or x bigger than 3. So these are the solutions that helps to satisfy this inequality. Similarly, these are the root for the second questions: -4, -1, and 2, negative, positive, negative, positive. You see smaller, so you choose the negative region. So in this case, you're going to choose x smaller equal to -4, or -1 in between x is in between -1 and 2. As a practice, we can first determine the root for the first question. The roots are -3, 1, and +2. Then we draw the number line. -3, 1, +2. We put down the sign in the correct interval, and we pay attention to the inequality sign used here. So it's bigger sign, bigger equal sign. So x is in between 1, -3, or x is bigger than 2. For the second question, likewise, you determine the root, you assume it to be 0. The root is going to be -4, -2, as well as 5. Then you can draw the number line, put down the sign, then choose the sign correctly. In this case, you will choose the negative region because of the smaller sign you see in the questions. So -4, x is smaller than -4, or x is in between 2 to 5. And that's it for this chapter. Thank you very much for listening and watching. Remember to read your additional reading material and work on some of the practices over there. Do the quiz. Thank you.